Let's talk about even and odd trig functions. One thing to remember is our algebraic definitions for even and odd. If a function is even, then if I evaluate the function at the negative variable, I get the same thing as the original function. If the function is odd, then if I evaluate the function at a negative variable, it's the same as if I distribute a negative throughout the original function. We can actually show that the cosine function is even and the sine function is odd. By definitions, points P and Q are as follows. So I have this is actually quite terrible. Sorry, this is supposed to be here, P. This is supposed to be here, Q. And this is supposed to be a dotted line between them. My triangle got off scale here. There we go. Okay, so if I let this point be P, now remember I'm on a unit circle. Radius is 1. So normally points are x and y, but if I'm talking about the unit circle, what's x? Cosine. And for the unit circle, what's y? Sine. So I can say, okay, for the point P, I'm going to let it be cosine and let the y be sine. Now, if I'm talking about the points Q, now if I, for example, if I want to talk about the angle of theta between my initial side and the point P, theta is here greater than 0 or positive, so I say positive theta. Here, however, if I start from my initial side and I open down, then theta here is less than 0. Theta here is less than 0, so negative. Okay, let me get a piece of paper so that we can draw this better, since my picture didn't come out very well. I'll draw it pretty big so that way we can talk about it. Excuse my crude circle here. Alright. Now, let's say that I want to talk about this point P. I want to talk about this point Q. Now, this point P and this point Q line up on the exact same value here on the x-axis. The point P here lines up for a positive y value. Point Q lines up for a negative y value. But they're the same equidistance from the x-axis. Now, if I want to talk about an angle from my initial side in standard position, from my initial side to the point P here, theta opening up, theta here would be greater than 0. So that my point P, having x, y coordinates, would be cosine positive theta, sine positive theta. Now if I want to talk about the angle here on Q, in this case, I would open from my standard position, initial x-axis, I would actually open down. So that means that my theta would then be negative, theta less than 0, negative. So that my point Q, being x, y, would be cosine negative theta, sine negative theta. Okay? Now, we had said that the P's and the Q line up at the exact same value on the x-axis here, which means that the x-coordinate for P and the x-coordinate for Q are the same exact value. So that means that the x-coordinate for P is the exact same as the x-coordinate for Q, which gives you the same value, meaning that cosine theta is equal to cosine of a negative theta. Now, we said that the P and the Q are equidistant away from your x-axis. However, this is at a positive y, and this is at a negative y. So they are the same number, different values. Okay? So to say that is to say that sine, well, let me see, how do I want to see this? Let's see. So I can say sine of the negative, right, the y value here, is the same as the y value here, just opposite sign. So is equal to the same y value here, but opposite sign. Now let's go back to our definitions and see what does this mean. Okay, now, for a function to be even, right here, okay, for a function to be even, the original function is equal to the function evaluated at a negative. Oh, okay. So the original function is equal to the function evaluated at a negative. This says that cosine is even. Okay, let's look at the other one. For odd, it says function evaluated at a negative is equal to a negative of the original function. Oh, okay. So function evaluated at a negative is negative the original function. So that means that this is odd. That's actually how we talk about evens and odds for trig functions. So I've got these written out for you. Which one's which? Cosine theta is cosine negative, even. Secant theta, which is actually the reciprocal of the cosine, even. Everything else is odd. Only cosine and secant, the cosine function and its reciprocal secant, are even. Everything else is actually odd. Let's see how we actually work with these evens and odds for problems that we might come across. Find the exact value of the trig function. Now, it could be that you are going to, let me grab the unit circle again. I should just keep it out. Okay. There we go. Okay. There we go. Trig function. Now, the question here is cosine of a negative pi over 4. Now, if you're using a regular unit circle and you don't have your negatives marked, you'll have to use the ideas of evens and odds in order to do this problem. However, earlier in an earlier video, we actually marked your evens and odds for you because we said, for example, this measure was a negative 30 degrees or negative pi over 6. This measure would be negative 45 degrees or a negative pi over 4, okay? And we marked them all the way around. Now, if I want to find cosine of negative pi over 4, cosine is even. This is an even function, so I can remove the negative. So that means that this is cosine of pi over 4. Cosine at pi over 4 is the x value at pi over 4. The x value at pi over 4, square root of 2 over 2. If I didn't want to use evens and odds, I could simply look at the x value at a negative pi over 4. Negative pi over 4, the x value is square root of 2 over 2. Let's look at tangent at negative pi over 4. Tangent is an odd function, which means that I move negative to front. So that means that this is a negative tangent, pi over 4. Well, that means that it's negative y over x. Well, that means it's negative. I go and I look at what pi over 4 is. Here's pi over 4. The y is square root of 2 over 2. The x is square root of 2 over 2. So that means that I'm going to get a negative 1. Very good. Okay. Fundamental identities. The reciprocals we've talked about a little bit. We said that, for example, sine of theta was a y. We said that Cosecant theta was 1 over y. This is like saying 1 over, well, y is sine, so I could say that's 1 over sine. If I wanted to talk about how could I talk about sine in terms of that, well, you can say it's 1 over secant, flipping your identities around. So these are our reciprocal identities. Cosine's 1 over secant, secant's 1 over cosine, cotangent 1 over cotangent, cotangent 1 over tangent. Quotient identities. Tangent is known as y over x, so sine over cosine. Cosine is x over y, so cosine over sine. And we'll use these a lot throughout the next sections. Let's look at a couple of examples using this. Sine is 2/5, and cosine is square root of 21 over 5. Find the value of the 4 remaining trig functions. First, let's find tangent of theta. Tangent is y over x, but I don't know the ordered pair. I don't know x, I don't know y. But what do I know? I know y is sine, and I know x is cosine. So I know sine is 2/5. I know cosine is the square root of 21 over 5. I know fraction division becomes fraction multiplication. I can't have a I can't have a radical in my denominator. So I rationalize. So I get 2 square roots of 21 over 21. Let's see if we can find the cotangent. Cotangent is x over y. Again, I don't know the point, I don't know what x is, and I don't know what y is, but I know that x is cosine, I know that y is sine. Cosine is square root of 21 over 5. I know sine is 2/5. Fraction division becomes fraction multiplication of the reciprocal of the denominator. The 5's will cancel. Square root of 21 over 2. Cosecant theta. Cosecant is the reciprocal of the sine function, so it's 1 over sine theta, which will be 1 over 2/5, or 1 times 5/2, right? Fraction division. Changing it to multiplication, simply getting 5/2. And lastly, secant is the reciprocal of the cosine function, so we have 1 over cosine, or 1 over square root of 21/5. Fraction division becomes fraction multiplication. Flip the denominator or multiply by the reciprocal. So we get 5 over the square root of 21. But I can't have a radical in my denominator, so I rationalize. So I get 5 square roots of 21 over 21. And that's how we use our identities, our quotient identities and our reciprocal identities.